1, lesson 6. This is lesson 6 of 7, so we're on the decline. We have one more lesson after this. This is the start of the final standard, which is the inverse relation. Okay, so we're talking about inverse functions. Okay, so simply, first off, if we're talking about inverse of functions, it's pretty important to know what a function is. Okay, so what's the definition of a function? How do you describe it? It's right here if you want to read it, but if you don't want to not read it, try. Okay. So what it says is a function is a relation of each element in A is mapped to one element in B. And simply what that means is, in an easy translation, is every x has one y. Every x only has one y. It can't go to two y's. If you go to two y's, you're not a function now. Okay? And so you can see this one right here, 1 to 2, 2 to 4, 3 to 6, 4 to 8. That one's good. Is this one good? Yeah, it still is actually, because even though different x's are going to the same y, that's okay. Okay, that's okay because -2 is not going to spots. So when you're looking at mapping diagrams, it's actually quite simple. You just look, is any of the x's splitting? Nope, they're all going one spot. So it's okay. All right? So every x has one y as your definition of function. So if we do the inverse of these, what they did was they flipped these. And inverse does mean flip, essentially. We're going to be flipping x and y. Okay, that's going to be the main things we're going to do today. Okay, and they did that. They flipped A and B. So if I flip this one, is it still a function? Yep, we're still good. How about this one? Oh, not a function now. We have splits. Those are splitting from the x side now. Okay, so that's a problem. So that's what I'm talking about. This you're looking for these. Those little splits right there. Whoops. Okay. Yeah, those right there are splitting, which tells us not a function. So down here in the notes, in case 1 is the inverse of function, it is a function, this one. In case 2, it is not a function on the inverse. Okay? Pretty straightforward, not too bad. Okay, so the domain of the inverse is the range of the original functions. So let me say that again. I know it's really wordy. You don't know what domain or inverse means, but what this is saying basically is domain of the inverse is the range of the original. Well, domain we think x, range we think y. So what happens? X and y flip. The domain of the inverse is the range of the original function. So essentially x and y flip. Okay, does that make sense? The converse to that is the range of the inverse, so the y of the inverse is the domain of the original. So you're just seeing that same situation. And if you take the inverse of something that is a function, it doesn't necessarily mean that the inverse is a function. So that's your 3 kind of bullet points to get started. The inverse of a function may or may not be a function. So let's kind of do a little funny thing here with words. So consider the operation of putting on your socks and then putting on your shoes. What would be the inverse operation? Say that again? No, not quite. Taking off your shoes, reverse, right? And taking off your socks. So the reason they do that there is to kind of show the undoing process of doing an inverse. You're not just switching a positive, negative. You're not just switching the order. You're switching the entire function. So you're undoing the function. And when you flip x and y and you solve for y again, what do you have to do? You have to get y by itself. I'm going to get ahead of the game here just because I want to show you why they talked about this. If I told you y equals 2x minus 1, I said find the inverse. Your process is you're going to switch these, and you're going to solve for y again. See how you're going to unwrap it? So you're going to take off your socks, or take off your shoes, okay, and then take off your socks. And so that would be the inverse. X plus 1 over 2 now would be the inverse. okay, which you could write as a slope, but we'll get that later. That's just a quick example of undoing after you flip. Okay, so let's look at these just simply. Okay, so Jacob, what do you think? Multiply by 2, what's the inverse? Divide by 2. Let's just do this column first here. Okay, Brooklyn, if I said square, what's the inverse? Yep, square root. We'll stay at that table there. Mo, what do you think it is for take the reciprocal? Well, tricky. Take the reciprocal. It's actually, so what does reciprocal mean? Flip, right? So if I want to do the opposite again, I would flip again. So take the reciprocal again. Okay? Last class actually said go back to normal, which actually is correct. So I gave Mo a tricky one, so we won't be hard on him. Easy there, Bricky. Be nice. Okay, reciprocal. 2/3 to 3/2, right? But if I want to do the inverse, then I would flip again, which last class said go back to the original or take the reciprocal again. So they put in the book take the reciprocal still. That's still the step. Okay? All right. What do you think there, Ben, for the last one? Order is important there, guys. Ben got it. Subtract 1 has to go first, and then, you say multiply 3? Multiply 3. That's important. Okay. Now, of all these, which ones are functions? So if I divide something by 2, is it a function? Yep. If I square root something, is it a function? So now this is the tricky part. Okay? When you square root, you technically have to put plus or minus. Right? So if I go, let's say that x squared is 25, and I square root, the answer is plus or minus 5, right? So that means I have 2 outputs. So that means it's not a function. And in the picture, we know you guys are good. I know you guys are good. We know that that's what the square root function looks like. But when you do the plus or minus, see that? That's the vertical line test violation. What is square root function? A straight square, yes. Yep. Right. Right. But square root not, and it's more the operation, because when we square root something, we have the plus or minus, which gives us the bottom of this here, which gives us a problem. Okay, so this one's no. Take the reciprocal. Yep, that's still a function. Okay. Even if you have reciprocal function with an asymptote, it's still a function because it's still past the vertical line test. Okay. And then you have your subtract 1, multiply by 3. That one is 2. Okay. All right, so now we're just going to look at things in terms of ordered pairs. We're going to do a little bit of looking at the graphs, and then we're going to do a little bit of actually the function work today. We'll get a little bit harder with the functions tomorrow. Okay, so today is kind of more the graphing approach with a little bit on the easier side of the function. So you guys will probably, most of the class finished their homework today, so you probably will finish it in class. You are 30 minutes shorter, so maybe not, but be close. So they just want me to write this function here in ordered pairs. So like this is my x's, these are my y's, so just write them as points. So they have 1, 2 here, so then it's 2, 4, 3, 6, and 4, 8. Those are my points. And they just tell you A is half of B. 1 is half of 2, 2 is half of 4, etc. Okay. Then they flip it and write the new points. Okay. Okay, so it says, notice the ordered pairs of the inverse can be obtained by interchanging the first and second coordinates of the ordered pairs. So it's simply you're just flipping the ordered pairs. This reinforces the rule the domain is the inverse. The bolts are. The domain of the inverse is the range of the original. Okay. The range of the inverse is the domain of the original. Okay, that part that we had bold earlier, the 3 points. Okay, just again, x and y flip. Okay, so going further, let's actually look at one we're going to plot here. So consider the following set of pairs. So I'm going to go, we don't need to see that anymore. We'll get down so we get all the graph. Describe the inverse of the function by a set of ordered pairs. So we're just going to flip these. That's all we're going to do. We're going to go -2, -4. We're going to go -1, -2. We're going to go 0, -1. We're going to go 1, 0, 4, 2, and 8, 3. Okay. Graph the original function and the inverse function. So we're going to graph both of them. Let's go ahead and just do little colors here. So I'll do this one in blue. So you guys can do it on your own. You don't have to really see me do it too much here. -4, -2, -2, -1, -1, 0, 0, 1, 2, 4, 3, 8. Okay, so here's roughly that one. Let's kind of leave it there for a second. So it's not a line. You can kind of see it's curving. Okay, my inverse one, we'll go back to red, so I wrote it in red. Okay, that one is -2, -4, -1, -2, 0, -1, 1, 0, 4, 2, and 8, 3. Okay. Draw a line that acts as a mirror between those points. You can kind of see that they are definitely doing something. They're related. See that? You can definitely see that they're related. So they're actually mirrored on the y = x line, which kind of makes sense, right? Because we're flipping y and x. So we're flipping over that line of y = x. Sorry about the little curvature there, but it's supposed to be straight. Okay. And so I already gave it away. The mirror line is y = x. So what I'm trying to explain to you is, you see, look at the distance. I always think about it in terms of distance. This is the same distance as that, same distance as that, and that's because my line should be better there. There, same distance, same distance. They're the same distance from that line, so it's pretty much jumped over it. Okay? And that's what flipping the x and y does for you. Okay? All right, any questions? We're going to get a little bit more complicated graphs here, but good news is the little hang-ups I had during period 2, we'll get over them, so it'll be better this time, right, David? Okay, so determine the inverse of the function by reflecting over y = x. Alternatively, select coordinates of some key points and interchange the coordinates and plot the new points. Here's your hint for your diploma question today. I would use this strategy. Okay, I would use this strategy a little bit in terms of how you plot your points. So not so much the inverse. It's not an inverse question, but I would suggest plotting the points of it's f times g function, but you'll see what I mean when I get there. But plotting the points can help you a little bit more than the algebra. So here, sketch the graph of the inverse of the functions defined by the following graphs. Is the inverse a function? So we want to work on getting the actual graph of the inverse function. So let's just go ahead and switch it up here again. Let's go blue for my inverse function. Okay, and just take some selected points that you can get and just flip them. That's all we're going to do. So let's do these main 3 first. And it's going to look kind of weird at first because you're going to see it's going to have a twist. Okay? And it has a twist because it's an absolute value. The absolute value is sharp-cornered. It changes direction quickly. Okay? So let's go ahead and look. So this right here is, and this is where I messed up this morning, this is by 2's. Okay? So this is 0, -6. Okay? So 0, -6 on the original, so the inverse is going to be what? -6, 0. Right? So -6, 0, I'm going to go put a dot there, which is actually right here. Okay? Let's go ahead and do this solid dot here. That is 6, 0. So that means I'm at 0, 6. Okay, let's do this dot. 6, 0. So here, I'm right there. So you kind of see, I got a point here, and a point here. So we need to figure out what's going on, because I can't quite tell. I'm assuming it's to be some sort of V. You may see it right now, but I didn't see it at first. So I'm going to try a couple more points to give me some more clarity. So I'm going to do this one. So let's do -8, 2. -8, 2. So that's going to be 2, -8. 2, -8. Okay. So now you can start to kind of see how it's taking form here. So that's a point, that's a point, that's a point. Okay. So it's going like this. Okay, let's get one more this way. So let's try this one right here. That's 8, 2. So then 2, 8. So I have 2, 8. Whoops, sorry, 2, 8. Oh, every time. 2, 8. Oh, now I can kind of see this. So it turned it. So it's here, the inverse is here. Okay, now let me explain this. So we said a couple things. We switched the points, which we did, right? We also said the inverse does what across the y equals x? It reflects. Do you guys see it reflecting? So let's look. Here's y equals x. Everybody in last class, you can see this, right? But they had trouble seeing this one. Well, look what's happening. What's happening is it's mirroring across it because it's going the same direction. So it's jumping here, jumping here, jumping here, because as this gets farther, the jump gets farther, right? And so that's what keeps happening as it's reflecting. Okay? Any questions on that? Okay? How about you try B? See if you can do B. Oh, sorry. Is the inverse a function? Bam. Vertical line test, right? It's going through 2 spots with the vertical line test. So right away, you know no. So it's not a function. The inverse is not a function. This is why, Hannah, this is why, think about absolute value, right? Absolute value has the same problem as square roots, that they have a plus or minus answer. So for example, this is how you know it's not a function. I know if I'm doing an absolute value normally. Let's just say it's absolute value x, right? Okay, well, absolute value of x, if I plug in -5 and 5, I get 5, right? So if I reverse that direction, I have 5 going to -5 and 5. Yep. So if you have 2 ways to get to a y, one direction, if you reverse it with the inverse, you now have a non-function because it's going to 2 different things for one value. Okay? Yes. Another way you can kind of see parabolas and v's are giveaways because look, they're going to go to 2 values. So like right here, this one's going to -6, 0 and 6, 0. So that means that 0 is going to 2 different numbers. Yeah. Okay, try B. I'll pause the video. Good check. Okay, so it's going to take a couple of key points here. So we have this right here. Again, they're going by 2's again, so be careful of that. It's -6, 0. So I want 0, -6. Let's get off of yellow here. So 0, -6 puts me down here. This point is 0, 4. So 0, 4 means 4, 0 is a point. So that means that's right here. Then here is 6, 0. So that means 0, 6 is a point. That right there, what's this giveaway? It's not a function. They're stacked, right? So I'm up here. Okay, good. There's a couple more you can do. You can do this guy right here. That one is 4, 2. So it's going to be 2, 4. 2, 4, so right there. And then you can do this guy right here too if you wanted, which is -4, 2. So it's 2, -4. And again, you see that stacked. And so here is the inverse function. So we did blue last time, so we'll stay blue. So the inverse function is this. The cool thing is it really, this one's a good illustration. The y equals x line goes right through it. Okay? can see that it's mirrored pretty well. Okay. So just in case you don't have it, not function. Not function. Okay. All right, so now we're going to dip into algebraically, and then we're going to be basically done. Okay, this is our last example here. Okay. Any questions on the graph before I go further? All square? Okay. So this right here is a box that I would highlight or put a star by. Interchange x and y in the equation and solve for y. That's how you find the inverse equation. You take x and y, you flip them, solve for y. Okay? So let's do this here. Consider a function defined by the equation 3x, y equals 3x plus 2. Find the equation in the form of y equals mx plus b for the inverse of the function. So do exactly what I just said. We're going to flip x and y. So we're going to swap those. So it's going to be x equals 3y plus 2. And we're going to solve for y. So we minus the 2 first. Divide the 3 to everything. People missed that last class. Last class is also really confused. X over 3 is the same thing as 1/3 x. X over 3 is the same thing as 1/3 x. I write it like that. Why? So you can see your slope. Okay, so you can see your slope. Okay, your slope's 1/3. X over 3, it's harder to see. Okay, so then we're going to graph the original and the inverse on this grid. So let's do original and red or black's fine. So 3x plus 2, we'd start here. We'd go up 3 over 1, down 3, left 1. So we're somewhere along here. That's this guy, the black one. We'll switch to green here for the inverse. 1/3 x minus 2/3. So minus 2/3 puts me right about here. That's up 1 over 3, down 1 over 3. So there's that inverse. That was a good one. Okay, and then you just want to see if you want to see the y equals x line, y equals x line is going right through it perfectly. Okay, so in this case, is the inverse a function? We have a line, right? Cool with lines, no problem. Okay. All right, so we'll stop there.